Yeah.
Okay, so here we are. It's the last day of classes for us. The assignment is nominally due tomorrow. You can take through Friday if you wish, but don't count on there being any TAs on Friday because the TA's schedule ends with the end of classes, so there may or may not be TA help available on Friday. So get any help you need tomorrow. And don't forget that in addition to submitting your assignment, you also need, there's a PS 11D, just a short questionnaire about how things went. You need to do that as well by the end of the week, 5 points. Any questions or problems about anything? Things going okay with asteroids? Yep. Well, the beat sounds are, you know, there's the background sound, boom, 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 boom. And one of the files is the boom, and the other is the boom. Yeah, they alternate, and they get faster. You know, it gets faster as you go on. It ratchets up the tension. Any other questions? Okay.
That doesn't say it now, but it does change.
Okay, today we're just going to talk about the final. Speaking of which, it's Tuesday, so it's in 6 days from 3:30 to 5:30. So it's not the usual day or time for class. And depending on your last name, it's not even the regular room. So if your last name begins with the letter A through G, please go to JTB 310. Otherwise, come here and bring your U card. And here's the map again, in case you don't know where JTB is. It's just a little bit northwest of here. The President's Circle.
What is JTB, what number?
310.
Thank you.
Okay? Please let your friends know about this if they haven't heard it already. Stefan is going to be doing a review before the final the same way he did before the midterm. And it's on Friday, we think at 12 and 3. You want to ask him any questions?
Yeah, I'm going to do one at 12, and then I'm going to do one at 3. Is there anyone who can't make either of those times? A few of you? Can you guys make 6? Raise your hand if you can't make 6. Raise your hand if you can't make any of those 3. When can you make it? You can't at all. Okay, so for the people who can make it on Friday, is there anyone who can't make any of those 3 sessions? 8 a.m.? That's not going to work. I will still be in bed. So let's go with 12 and 3, and raise your hand again if you can't make the 6, but with the exception of the 2 that there's just one.
You can make 6, but you can't make the other 2.
You can make 6, but you can't make the other 2. So there's just really 4 of
There's
them.
4.
5. So I'll talk with Joe. Maybe I'll have one at 6 for the 5 of you. That'll also give other people a chance to come later if they want to, or come to a second section if they want to. So, yeah. Yeah, we're talking about that. If we get my computer set up, we can do a live stream. Can't hear you. Maybe. Definitely 12, definitely 3, maybe 6. And maybe live stream.
Okay. Okay, so basically I took the review slides for the midterm and I added stuff that we've done since then and used yellow to indicate stuff that wasn't there at the midterm. And there's something like 40 slides, so I could hang up here and talk my way through 40 slides, 2 minutes per slide, and that would about eat up the class. I'm not sure that's the most effective way to review. I'd much rather answer questions. So, go over things you don't understand, things that were hard to understand, because you can look at these slides yourself. So,
I wanted to clarify. So, are they going to be tested on stuff like linked lists and what kind of algorithms?
yeah, I'm not gonna test on the previous two lectures, the sorting algorithms in the linked lists. Okay. So why don't I start right here and just ask for questions? Is there some part of the course, some topic we've talked about which you have particular questions? Yes.
Can you just briefly go over interfaces?
Okay, go over interfaces.
Yeah.
Okay. So let me do it here in Eclipse.
Can you clear up the linked list, whether you're going to do it or not?
I just said I wasn't.
Oh, did you? Oh, I wasn't listening.
Okay, so let's call this we'll create an example interface. All right, so there is the beginnings of an interface. So I've created this thing called example interface. And now suppose I wanted to have a class that implemented that interface. What would I have to do? Yep.
You just read at the top of the class you made implements that interface.
Okay. So I'll create another one called example class. If I want to implement that interface, I say implement example interface. And having done that, what does that let me do that I couldn't do before? What can I do with example class objects that I couldn't do before? Yeah?
You can treat example class as an example interface type. So any
Okay.
method that requires an example interface, you can give it an example class.
Okay, so let's add one more here. I'll call it demo. And I'll put a method in here. I'm sure I did that. So here I have a method called f that expects an example interface object as a parameter. So up here, I should be able to do this. Example class, sorry. So the only reason that works, see, this method expects an example interface object. I'm obviously giving it an example class object. Let me make this one static. And that works because we said right here, an example class object is a kind of example interface object. Now, if I comment that out, suddenly I have an error back here. I can no longer pass this object to here because this object is no longer an example interface object. So that's the thing you buy by implementing an interface. You can use your objects in a context where objects of the interface are expected. Yeah?
Can you explain like why you had to make that static and why it couldn't be not static?
Okay. What was the problem when this, let me get rid of all the errors here first. Why is this an error? Why is F underlined in red? Yeah.
Because you're not calling it on an object?
Right. What you're looking at, she said, I'm not calling it on an object. F is a non-static method. So to invoke it, you've got to say object.f. You've got to tell it on which object to invoke F. And we're not doing that. So to call it, we'd have to do something like this. Well, what could I put in front of F so that it would no longer be an error?
This.
Well, can I say this? Well, now this is underlined. What's the problem with saying this? Yeah?
I'm not sure, but is it that there's no constructor?
No, there's always, if you don't put any constructors, you get a zero argument constructor for free. Well, yeah.
Class demo is not an example, or is not an example interface. Does not make
No, it has nothing to do with interfaces. Why is this? Why is the word this in that main method? Why is that meaningless? Yeah?
This represents an object, but demo cannot instantiate it to an object.
Well, sure. I can say I can create a new demo object. That's not a problem. Yeah?
Because main is a static method and it's never going to have a this.
Okay. He said main is a static method and it's never going to have a this. What does this mean? What does this stand for? 8 words.
The object on which the method.
The object on which the method was invoked. Well, was main invoked on an object? It's a static method. It was not invoked on an object. And so this has no meaning inside of a static method, because static methods weren't invoked on objects. So you're only going to see this inside a constructor or a non-static method. So what would it take if we wanted to call F here? We can't put this there. What can we put there? D. Because now we have an object. You say invoke F on D. Okay? Now, back to the interface question. Suppose I go back here and I say, I add this. I say public int G double X. So what I'm saying is, if you want to claim to be an example interface, you had better provide that method. And example class does not provide that method. And if we look at it, it'll say the type example class must implement the inherited abstract method example interface.g. So we'll add unimplemented methods. And then it's happy. So an interface is just a way of, you can advertise your class as implementing an interface, which lets your objects pose as object to that interface. But your responsibility is to implement the methods. So let's say we implement this and we just do this. Okay, so now I've implemented G just to say hello. Back here in demo, suppose I do either E dot G. Why does that compile? Why is it okay to call the method G on that object E up there? Yep.
Because it's an instance of example interface.
Right. E is an object of type example interface, and we know those methods, they have methods G on them. So the interface contains the method G. Now, so let's see. To F, we're passing a new example class object. Let's go back to example class and add another method. Okay? So now we have method G and a method test in example class. I am calling this method F and passing in example interface E, and now I want to say E dot test. Why does that not work? Yeah?
Because there's no test method in the interface.
Right. All we know is that E is an object that composes an example interface object, and there is no test method to find that interface. But, look, we're passing down that object right there, that example class object, implements the interface. So why is this not okay? We're calling F, we're passing it, you can see right here. It's never called except with an example interface class object, an example class object. And yet we can't call the test method on it. Why not? Yeah.
I mean, the compiler doesn't know that the only time you ever call it is with the example class object.
Right.
So it just doesn't work.
Right. It doesn't, this could be called later from somewhere else where we're not passing in an example class object, we're passing in something else. Now, we happen to know it's an example class object, so how could we make this work? We do something like this. Okay. Now it's happy again. So what we're saying here is, well, I happen to know that this object is actually an example class object because I can look at the program and see that. And so we're going to ask the Java to treat this like to treat it like what it is, an example class object. Then we can invoke the method. But if we happen to call this method here with something other than an example class object, this cast will fail and it'll get an exception. Yeah.
So if you check if it was an instance of example class, you still have to typecast it before you.
Yeah, even if so I could do this. I could say if E So this would make it so that the runtime exception is not thrown if the cast fails, but I still have to do the cast. I still can't do that. So, does that help with interfaces? Oh, whoever asked the question originally? Yeah?
So, would it be wrong if you like try to cast it and then you did E.test? Like right before you did.
Yeah, I could do this. Here's another way to do it. I could say so that says cast it and then apply the test method on it. That's another way to do the same thing. Yeah? A little louder.
In programming, there's ISA and HASA relationships. I put that interface and inheritance, which is which.
Well, so when you have a class A extends B, would you say that A, well, is a B, or would you say that B is a, or would you say A has a B, or would you say that B has a? Which you think describes the situation? Class A is extending B. So what can you say about the relationship between A and B? Okay. Let me, you got an answer? Yeah.
A is a B.
Right, A is a B. B exists, A extends it. So A is a kind of B. Right? You can use an A wherever a B is required. That's what ISA means. Now, what if we do this? What if instead of saying extends, what if we say implements? Now, B is an interface, A is a class. What do you say now? Okay, we got to vote for HAZA. Remember my rule for ISA. We say that something, X is a Y if you can use an X wherever a Y is required. It's the same. So both of those are ways of setting up what is called an is-a relationship. So A is a B, meaning if some method expects a B as a parameter, you can pass in an A, and that's okay. Now the reverse isn't true. If some method expects an A as a parameter, you can't pass any old B in. Yeah?
Can you go over super and what exactly that means?
Okay. We'll do that, and I'll make a note to myself here. But we still got this question here. What is HAZA referring to? How do you set up a HAZA relationship? Yeah?
You build an object inside of another class. So like in the C class, you build an A object, class C would have it.
Okay, so we say class C, and then it just contains now hold on. And maybe it has some other instance variables. So in that case, we say that an object of type C has a A. It contains an A in it. But there could be other things in it. Maybe there's a private D. So C has an A. C has a D. So if all you need, if you just need to implement a class, if you need it to contain a reference to an object of a given type, you make it an instance variable. If you want to set up an ISA relationship, which is a stronger thing, you use inheritance or interfaces. Yeah?
So it's basically just like our controller has a ship, I guess?
Yes, yeah. So the controller class has a ship. It's not a ship. You wouldn't say the controller is a ship. You say the controller has a ship. But you would say that a ship is a participant. It's a kind of participant. A bullet is a participant. But you could not say a participant is a bullet, because you might have a participant object that's a bullet, but you might also have a participant object that's a ship or an alien ship or whatever. Okay? Yeah?
I'm still trying to figure out why it's not B as an A rather than A as a B, because I try to think of it as like the like a fruit and pear, for instance, right? The A would be considered the fruit, like a fruit class, and then pear would be the B.
No. The other way around.
Why would it be?
Well, typically what you would say about a pear is, suppose you know lots of things about fruits. Okay? You would say a pear is just like a fruit with these differences. So a pear is a fruit.
I think he's asking that because I think he thinks that you made A first and then you made B, not you made B first and then A extends it. Just because the word you had it.
Yeah, he just has it backwards. It's pear extends fruit.
Yeah.
He has it backwards.
If this were a program, you would say class pear.
He just has the letters
Extends fruit. And it's correct to say pear is a fruit, obviously. But it's incorrect to say that any fruit is a pear. Thank you. Yeah?
In the practice one, we had a set of questions about what would throw an exception.
I don't remember that question.
Set of constructors and stuff.
I'll give you a chance to remember it. Well, I'll make a note right here. Let's see what this does. Copies it. Okay. Share, that's what I want to do. What I want to do is just get a new page, but I don't see any way to do that except this one. Trash this page. Let's save it. Okay, so we want to know about super. All right, so to talk about super, there is this and super, which play similar roles in programs. So it's good to talk about them together. So we know that this, well, so I'll say this way. So you can see this is super in two ways, either this all by itself or this being invoked like a method. So in this case right here, what does this refer to? You already said it. The object on which the method was invoked. Okay? What does super refer to? Yeah?
It refers to like a higher up class, like whatever it extends. If there's a method in it, you can use super of that.
Okay. So basically, think about it this way. Suppose you have a class A that extends a class B. And you're in some method. This will refer to the object. So this refers to the object on which the method was invoked. What type is this? What type of object is this? Right. So this is a type A. Super also refers to the object on which the method was invoked. But it's as if, it's sort of like super is like what you get if you cast this to a B. Okay? This refers to an object of type A, but an object of type A is also an object of type B. So it's sort of like this, not exactly, but super just refers to the same object, but it refers to it as if the method as if the class hadn't been extended. So where do we use super? Where would you see super? Really only see it in one way. Yeah?
If you want to only add a few things to a method from the previous object, but you still want all the old things from it, you call super.
Okay, well, you don't, so where you'd see us like this. Super.f. That just says, suppose f has been overridden. Super.f refers to the unoverridden original method. Okay? So that gets this side. Okay, they're both references to the object to which the method was invoked, but super refers to sort of the original, gives you access to the original versions of all the methods instead of the overridden ones. What about this sense right here? Where do they show up? Yeah?
The very first constructor.
All right, the very first line of a constructor has to be either a call to this or a call to super. And if you leave it out, if you don't put either one in, what's put in for you automatically is this. This is the default. So what does it mean for something like this to be the first line of a constructor? Anybody? Okay, anybody want to guess? Thank you, go ahead.
It has to like pass all of the super's conditions for the constructor.
That's more closely related to this right here. Why would a constructor have something like this call right here as the very first line? Yeah?
You want to pass all the variables to a different version of the constructor in the same class.
Okay. This thing I put a box around amounts to a call to a different constructor in the same class. Now, where did you see that? What example, what assignment did I give you where I had a constructor like that? Well, actually, I'm not sure if I put it in.
It's a participant countdown timer.
Okay, how does that work?
You pass, I think it's an object and time, and then optionally you can pass payload. If you don't pass payload, the countdown timer passes null as the payload and the constructor in the class.
Okay, so let me you save that. I'll take what he just said. Actually, I'll just look at the code. Let's go into asteroids here, into source, participants, game, participant countdown time. And you can see that there are two versions of the constructor. There's a constructor that just takes a participant and a number of milliseconds. And there's one that takes the participant and an arbitrary object and a number of milliseconds. And look what this one is doing here. So how could you describe this button? Used to work, but it doesn't. How could you describe what this thing here is doing? You call that version of the constructor. Yeah?
It's basically, it's just calling the second constructor that you have and passing null as a parameter.
Right. It's just saying, let's pass the buck. This one just got called and was given a participant in milliseconds. Let's call this constructor and let it do the work, and we'll pass it null as the middle parameter. And this one then does the work. It lets us, you know, what if we didn't do it like this way, what would we have to do? How could we implement this constructor right here if we didn't want to pass the buck to the second constructor? Yeah?
You would just copy what you have down there, except for this payload, you put null.
Right. We just take this, we copy it up, we'd say payload is null. Anytime you find yourself copying code, there's generally a better way to do it. And the better way here is to say, okay, we'll let the other constructor do the work, and we'll just give it a default value for the middle parameter. So that's why you would call this from a constructor. Why would you call super? Yeah?
If you didn't see that second one, would you put super and then input instead of null what you want?
Well, in reality, because this one does not have a call to this or super, the compiler will put in this for us. So essentially, that's how participant count, the second constructor is defined. So the point is that when you have an object, let's say you have an object here, it's going to contain all the instance variables your class puts in it. So you're going to have these instance variables. But also your base class has instance variables, and they'll appear there. The constructor, so let's say we got a case where A extends B. So these are A's instance variables, those are B's instance variables. Here's an object. You call an A constructor, which of these variables can it initialize directly? Right. A's constructor can only talk about these instance variables. For these up here to be initialized, you need to call a base class constructor, and that's what super does. So when you call super, you're saying call call the constructor in the base class and let it initialize its variables. Yeah?
When you're done with his, the question about the test, can we go over the stack there a little bit?
Sure.
I have that question if you want it. Did he ask earlier?
Sure.
On the test?
I have it here.
Here.
He's got it on paper. I like that better. Yeah?
All right.
So does super only refer to the class that it extends its constructor, or does it also refer to its other method?
Well,
I don't know,
so super with parentheses after it would only appear in a constructor, only appear as the first line of a constructor. So that's a call to a base class constructor. The only other place you'll see super is when you see super.f. Then that's referring to the version of f in the base class, not the version that got overridden in the derived class.
Okay, and then I've seen parameters in those
Sure.
in the .f, and is that like overriding previous?
No, if f in the base class takes 2 parameters, you'll have to pass 2 parameters here. If it takes no parameters, then you use empty parentheses. It's like any other method call. You've got to provide the parameters. Yeah?
So if you had like an A, B, and C class where B extends A and C extends B, if you called super in the B class and B overrid, I mean, if you called super in the C class and B overrid the A class,
Well,
that method would have called the A1 or the B?
let me just do it with this example right here. So we got A extends B and B extends C. So C is the most fundamental class that was extended to contain B is extended to contain A. So the A constructor can deal with these variables. Then you call a super constructor. It initializes these variables. How do these variables get initialized? Yeah, B's constructor has to call the superclass constructor as well. So A doesn't know about C. A calls super and then initializes its variables. B calls super and then initializes its variables. And C just initializes its variables.
So you wouldn't be able to call super and C it?
Right, you can't do super.super or anything like that.
But if C's not the highest class, A's the highest.
Oh, I changed your example because I already had it written here. This is, I've got here A extends B. Put my palm in the wrong place.
So if A calls super, it'll refer to B's constructor instead of C's constructor.
Right. When A calls a super constructor, it's referring to a B constructor, not a C constructor. But when B calls super, it refers to a C constructor. Yeah?
So when you have super without calling a function, what kind of like parameters do you use it, or how do you use parameters?
It just depends on, so when you call super with parentheses from a constructor, okay, the base class has some constructors. If it has, let's say it has a 0-argument constructor and a 2-argument constructor. You just give parameters to super depending on which of those constructors you want to call. Same goes with using this with parentheses after it. Okay, so the question was, which one are we looking at here?
The very bottom one.
P.
Okay, so I was asking, here's some expressions. How can we cause them to throw an exception, right? So one of them is we declare a variable. And then we do a sub. So what would cause this expression right here to throw an exception? Yeah?
Any number more than 4 or less than 0.
Right, any number above 4 or less than 0. So we could say A of 6, for example. That's pretty bad.
Why would putting 5 in there?
Why would 5 cause an exception?
Oh, never mind, indexing.
That causes an exception too, because the valid index is from 0 through 4.
Question in one of the labs was, is -1 an exception, or does it cause a compile error?
Oh, I would call it an exception, but it may well cause compiler error. But I would have taken that as an answer.
Okay.
It definitely does not cause a compiler error.
Okay, so you get an exception. And I guess the reason it doesn't cause a compiler error is maybe you want the exception to happen. Okay? Was that the one specifically the question was about, or all of them?
It was his question, I just had to.
Oh.
The overall thing, that was a little.
Okay. So then we got string s equals something. And then we ask for the string's length. So what could we assign into s such that when you took its length, you got an exception? Yeah.
No.
Yeah, null is the only thing that comes to my mind. Any non-null string that you put in there would have a length. Yeah.
Yeah, that's what we answered in the lab, but I was wondering, could you put in a string that was so massive that it also screwed it up?
No, there's a limit to how big a string can be, just like there's a limit to how long an array can be. So you could get an error creating the string, but once it's successfully created, you can get its length out. Yeah?
I heard someone ask this and I wasn't sure. Couldn't you put null in for a couple of these to get an error or an exception?
Well, you couldn't put a null here. That wouldn't cause an exception. That would be a compile error, because you can't pass null and expect an int. There's another one here where you say int n equals 7, and then you do n divided by something. You can't divide, you can't use, you have to provide a number here. And null is not a number, so it couldn't use null. What could you do to cause an exception? Yeah, use 0. And the last one was you store an object here, and then you attempt to cast it to an integer. Okay. What could we do to make that cause an exception? Yeah. For example, a string. Anything that won't cast to an integer.
One of the questions in the lab was, what about a double?
What about a double? It's a good question. I don't know. I'd have to try it out to see whether a double could be cast to an integer. I know a double can be cast to an int. I don't know whether double with a capital D can be passed.
A lot of people said that it would just be rounded or truncated.
No, when you cast a double to an int, it is truncated. But if I were grading this, I would say, yeah, that's okay. Basic idea was anything other than integers.
Just on the string as well, since strings are objects, they default to null, right? So if you did the string s and then the semicolon, and then you did s.length, that would be the equivalent of string s equals null.
Well, no, if you just do this, if you say string s, and then you say s.length, that won't even compile. You must initialize a variable before you use it. You must initialize a local variable before you use it. Instance variable is a little bit different, but for a local like this, yeah, you couldn't even get to that point. Yeah?
So for the same thing, you wouldn't be able to do object O equals null, and then that would go on exception?
Right here. So if I said, is that what you're asking about? Okay. Would that cause an exception? It wouldn't. You can use null. Null can stand for any type, any reference type it wants to. So, yeah, null is a valid integer. It can be stored in an integer variable. Now, it wouldn't work to do this. You couldn't cast null to an int primitive. You can cast null to any reference type. Okay, that's that. What other questions? Yeah?
Earlier we mentioned the extends and implements keyword is a relationship. And you said class pair extends fruit. So you could also say class pair implements fruit.
Yeah, you could say class pair implements fruit, just depending on whether pair is an interface or a class.
And the main difference would be when if it's an interface, it doesn't have any methods.
Well, if it's an interface, it has methods. They're just headers, though. They're not implemented.
Well, they're not implemented.
Yeah?
Can you kind of go over a little bit about abstract classes too, how they differ from interfaces?
Okay. So we're asked about abstract classes there. So let's find an abstract class in this program. And I think the best one is participant. So you can see right here, it says participant is an abstract class. Nevertheless, look at all the things we know. Participants have speed, rotation, position. They have a border. They know whether or not they've expired. They have a reference to a library of sounds. They have a constructor that creates a participant. You can expire. You can set velocity, direction. You get all this functionality with participant. And it's a good thing. You don't have to re-implement that. Every time you extend the class, you get all this stuff for free. You just have to change the things that are different. So we keep going and going and going. Look at all these methods you've got. And we're finally, I hope, going to get to this one right here, which is an abstract method. And this one here, which says is abstract and says what you do when you collide with a participant. And I think that's all. So what was the sense? Why are those methods? Because these methods are declared abstract, you cannot directly create a participant object. You can't say new participant. This class is intended only to be extended into concrete classes. Why did I choose to make collided with and get outline abstract methods? Why didn't I implement them? Yeah?
Because whenever you have a participant, it's pretty much always going to have an outline. You're
Okay.
going to see it, and then it's going to interact with something.
Okay, clearly, get outline, we declare these methods because every participant needs an outline and every participant needs a collided with method. And in fact, there are other places in the code where we call the get outline method every time we draw a participant. And in fact, right here, here's the move method. It calls that abstract method. And then eventually it takes that shape, it transforms it in various ways to do the motion. There's the draw method. It gets the outline and draws it. How do we get away with calling this method right here, get outline, when it's not even implemented? It's called from the same class, even though it's not implemented. How does that possibly work? Yeah?
You override that method?
Right. Okay, so first of all, the reason you can't ever say new participant is then we would have a problem. If we just directly create a new participant object and tried to run the draw method on it, it would end up trying to call get outline, and it would fail because get outline is not implemented. So what happens though is when we create a bullet class, we give it a get outline method, and it inherits the draw method. And when the draw method is called, when this inherited draw method is called on a bullet object, what does get outline refer to? Yeah?
The get outline in the bullet class that you
Right.
implemented.
The get outline in the bullet class that we've overridden. So this is a very common thing. You inherit a method that calls an abstract method. But in addition to inheriting the draw method, you also are forced to override the abstract methods. So why, though, did I make them abstract? Why not just implement them? Why didn't I implement getOutline, for example? Why did I make it abstract? Yeah?
So that, I guess so many different objects can inherit like certain properties.
Okay, so he said that I made it abstract so that other methods could inherit it. But the same would be true. The other classes could inherit it. Other classes can inherit getY. Other classes inherit draw. Why did I treat getOutline and collided with specially? Yeah?
So you're forced to override it, so you always have an outline and you always have a
Okay, so that's one reason, is I want you to override it. I don't want you to forget to override it. So if I want to force you to write custom code for your class, I make the method abstract. Okay? What's another reason that I would make a method abstract? Yeah?
Because it's different for every single one.
Right. Right. The outline is different for everything. What should be the outline of a generic participant? Suppose I did implement it. What outline should I use? Should I draw a circle? A dot? A rectangle? I didn't know. So I just made it abstract, so I didn't have to decide. It doesn't matter, because I want it to be overridden anyway. And the same thing goes for collided with. What should be the default behavior when you collide with something? I decided that that's just got to be custom, depending on the concrete class. So I didn't decide what should happen by default. I just left it to the overriding classes to decide. So I can decide some of this stuff. And I can decide that I'm going to use getOutline and other methods, and collided with and other methods. But to make it all work in the end, the concrete class has to provide those bits. It has to implement those abstract methods. Yeah?
Can you explain why you would make getOutline protected and then collide with public?
Okay, why did I make this public and this protected? The short answer is I saw a need for classes outside of this class to call collided with. But I did not see a need for getOutline to be callable from outside the class. The only reason you need getOutline is to draw it. And I'm calling, and yes, draw is public. But I didn't see a need to make the outline a public thing. So I could have done it another way. It's really not a deep answer. Yep?
So the only thing that can use getOutline is this draw method here?
Okay. Where can getOutline be used from, given that it's protected?
Anywhere in this class?
Anywhere in this class, but where else can it be used?
Anywhere in the package.
Yeah.
Any class that extends this class can access that protected method. And that's a good thing, because it has to be overridden. Now, this would be a bad deal. If you made an abstract method private, it's going to complain. What's bad about a private abstract method? Yeah?
So if you have a private method, that means it's going to be used inside the class itself, and that's not a typical behavior of an abstract class.
Well, yeah. So it can only be used inside the method. But furthermore, how could it ever be overridden? Right? The class that a class that extends participant would not be able to override it because it's not accessible. And so the error here is going to say, you can't use private for an abstract method. That would make it unoverridable, and then it's just useless. Let's take a few minutes break, and then I'll take some more questions. And if there aren't any, I'll wrap things up.
Oh,
Okay, any other questions I could answer? Yeah?
Do we need to know anything about ternary?
The ternary operator? No, I really haven't talked very much about the ternary operator. I will tell you, I've probably told you, I avoided it for like most of my life. And it's only in the last few years that I've come to embrace the ternary operator. So, I think it can, I know it can simplify code sometimes, but it took that long to get used to how it looks. It's basically a conditional which is an expression as opposed to a conditional which is a statement. Other questions? Yeah?
When would you use specific maps, true map and hash map?
Okay. So we've got tree map and hash map.
Let's see.
That's not right. I didn't mean to do that. I meant to save it. Okay, why would you use a tree map or a tree set instead of a hash map? They both provide the same basic things, the same mapping capability. Yeah?
For the tree map and tree set, the keys are arranged lexicographically.
Okay, so for a tree map, the keys are ordered. So if you iterate through a tree map, you just say, "Give me all the keys." It'll give them to you in sorted order, which may be something you want to do. I mean, imagine you have a tree map and you want to print out a table that has the keys and the values, and you want the keys to be ordered. Use a tree map; they'll come out ordered. What's the cost of having a map which maintains the keys in order? Right. So a hash map is faster. So this is something you're studying in 2420, actually, is this various ways to represent sets. So a tree map uses what's called a binary search tree. So you'll be writing programs that build not just linked lists, but trees like that. This is called a binary search tree. That's what tree maps are based on. And hash maps, you'll be learning about hash tables. And all a hash table is, it's sort of like an array, except the keys that come in can be other types, like strings. Yeah?
It's not related to this, but at the end of the linked listing, at the end of the lecture, you're saying it wasn't going to be covered on the fund because I was trying to find it in Oracle.
Yeah, so I'm not going to cover the sorting algorithms or the linked lists that we did the last two lectures on the fund. Yeah.
So, what do you mean by faster? Do you mean it's like faster finding stuff, or faster in what way?
It's faster to put things in, faster to take things out.
Okay.
Not amazingly so. Often that's not the deciding thing. But the basic idea is when you insert to a binary search tree, what you have to do is figure out where to put it. It's going to go somewhere at the bottom of the tree. So you've got to write code that follows through the tree and goes to the right spot. Whereas with a hash table, it's sort of like an array. You just go stick it in the right spot. Yeah?
Can you also sort tree maps by value?
Can you sort them by value, sort tree maps by value or tree sets by value? No, the best you can do is get the values out and then sort them. Yeah, they're just ordered by key. Yeah?
What's the difference between tree map and tree set?
Oh, okay. Tree map, so basically what's the difference between a map and a set? Okay. Well, a set is just a collection of keys. A map is a collection of keys with a value associated with each key. So you could talk about a set of telephone numbers, or you could talk about a map that maps names to telephone numbers. So in the first case, the telephone numbers are the keys. In the second case, it's the names that are the keys and the telephone numbers are the values. So if you're talking about key value pair, you want a map, which is a generalization of an array. You want, just talking about sets of things, just keys, then you want sets. Yeah?
When it says order, does that mean like if the key of strings will be in alphabetical order, or?
Right, so when I say a tree set maintains its keys in order, it sort of means alphabetical order. It really means they're maintained in lexicographic order. And the difference is alphabetical order just talks about A through Z. Lexicographic order generalizes that idea to Unicode. And, so what do? What comes first, an A or a $sign? Well, just whatever one comes first in Unicode is what comes first when you sort in lexicographic order. Yeah?
Remember the pros and cons of tree set and hash set?
The pros and cons of tree sets and hash set? Exactly the same for maps.
Oh, okay.
Tree sets are ordered, hash maps are faster. Slightly faster. Yeah?
And don't hashes not have duplicates in a tree map, right? But not,
You never, in none of these do you have duplicates. So the keys have to be unique. Now, there's a burden on both of these. When you're using a tree set or a tree map, your keys have to be things that can be compared, or they can't be sorted. So it has to be some way to compare two keys to decide what comes first. And we've only ever used tree sets and tree maps with keys like integers or strings, which have built-in ways to compare them. But if you want to create a tree set containing participant objects, you'd have to define some way to compare participants. To use a map, to use a hash map or a hash set, you have to define an operator, a method called hash code, which takes in an arbitrary string and turns it into an int, or takes in an arbitrary participant and turns it into an int. And again, we've only used classes that have hash codes defined for them. So if we wanted to create a hash set of participant objects, you'd have to implement a reasonable hash code. Again, that's a big part of 2420 is studying these trade-offs. Yeah?
It's escaping my mind at the moment. Is there a difference between one holds duplicates?
Between what?
One holds duplicates and one doesn't?
No, all sets, no duplicates. All maps, you cannot have duplicate keys. You can have duplicate values, but not keys. Okay, I want to wrap this up with just sort of a larger thought. Why are programming languages the way they are? All right, we spent all semester studying programming languages, or studying a programming language and learning features and such. And it can seem like it's just sort of this endless list of details that you have to master. We learned stuff the first week, the second week, the third week. It all builds, and after a while, it might seem like you're being crushed by the detail. But the truth is, you've learned, 90% of Java. Right? There are a few more fine points you can see in 2420. You've mastered most of Java. And when you know most of Java, it's easy to learn most of C, or most of C++, or most of Python, whatever you want to do. So my question is, why, where did these things come from? Why are loops in the language? Why is inheritance in the language? Where did this thing called a programming language come from? Why do you have private instance variables? Why do you have methods? Why do you have classes? Why do you have inheritance? Yeah?
They solve problems.
Well, they're useful for solving problems, and yet, we were able to solve problems in the 70s with programming languages, even though we did not have classes, we did not have inheritance, we did not have interfaces. Yeah?
Because using GoTo is very, very painful.
Well, we knew in the 70s to avoid GoTo. We had loops. Yeah?
It'll prevent redundancy. If you have to keep writing the same code over and over.
Okay. He said it prevent redundancy. Yeah?
To make the code easier to read.
Okay, to make the code easier to read. Yeah?
I guess someone, like people just like, saw they were doing the same things over and over again, just had to implement something to make it
Okay.
easier.
So essentially what he said is, you know, as people got experience writing programs, they could look at the program and say, you know, it'd be a lot easier. I'm doing this thing over and over again. It'd be nice if the language would do it for me. So the tools just naturally improve. But the bottom line is, if all you care about is writing small programs, it doesn't matter what the language provides. You can get a small program to work. The problem comes with writing big programs. So the reason programming languages are the way they are, and the reason tools are the way they are, the reason Eclipse has so many features, is because you're trying to make it possible to write big programs. Because when programs get big, there's suddenly all these details you have to manage. And there are plenty of programming projects that have failed despite spending millions of dollars because the program got too complicated for people to understand. All the interactions were impossible to understand. I want to make a list here of aspects, things you've learned this semester about Java or about Eclipse that are there to make it easier to write large programs. Now, it's hard to sell this to a beginning class because they've only written small programs. You're sort of getting a taste with asteroids. It's a little bit bigger. What could I add to this list? What are things that exist to make it easier to write large programs? Yeah?
Classes.
Okay, classes. That's a good thing to put number one. Because it lets us create new types of things. Yeah?
Inheritance.
Okay, inheritance. Because it lets us create new things on the cheap. You don't have to do it from scratch. We just say what's different from what came before. Yeah?
Polymorphism.
Okay, polymorphism in general. Inheritance is a form of polymorphism. What else? Yeah?
Loops.
Okay. Sure. So someone mentioned goto. Actually, I made fun of the idea that we didn't know about loops in the 70s. But in fact, the first language I used had no loops. Instead, it had what's called a goto statement. And basically, a program would look like this. Statement, 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 statement. And you'd say goto statement 50. And there'd be some statement up here which was numbered 50. And you could, anywhere you chose, you could put a goto and hop somewhere else in the program. And it was even possible, I believe, to hop from the program into the middle of a method. Or they weren't called methods. And then from a method out. So that led to what was called spaghetti code. And languages eventually got rid of the goto in favor of, instead, what language designer did was look and see how gotos are being used and provide for loops, while loops, and so forth. So instead of simulating loops with gotos, they just provided loops. What else can I add to this list?
Abstraction.
Okay, abstraction. Yeah, that's very important. That's what lets you look at something complicated and think about it more simply. Yeah?
Methods.
Okay, methods sort of go along with classes up here. Those are big forms of breaking things into, breaking program into smaller pieces. Yeah?
Java documentation.
Okay, Java doc. Just imagine if, to use the Java library, you had to go read the code from the Java library and find out what the methods did. Suppose your only clue was the name of the method, then you had to read the code. That wouldn't be a very good world to live in. Yeah?
Like the compiler warnings?
Okay, compiler warnings. Getting more into tools here. Yeah?
JUnit.
Okay, JUnit lets you test things. Yeah? Okay, just the idea of libraries. Yeah? Okay, so public and private. And the important thing here is there's a distinction. In private, vitally important. Private, by making things private, you reserve the option of changing them in the future. Without private, once you implemented something and started being used, it's hard to change that private thing. What else do we add to the list? Yeah?
Can you add encapsulation?
Okay, so encapsulation is related to what we just said. But think about encapsulation is, you can use a method without knowing what goes on inside the method. You just have to look at the Java doc on it. And you can use a class without having to worry about the details of how it's represented. Yeah?
What about the garbage collector?
Okay, that's a good example. I always tell this story. I've come to doubt whether it's true or not, but let's pretend it's true. And the story goes that there's some place like Yahoo, it was some company that had to maintain large servers, large server farms. And they were using C++. And in C++, you don't get garbage collection. You have to say, when you're done with some memory, you say delete. And if you do it too soon, your program fails. If you do it too late, you run out of memory, possibly. But their programmers were making so many mistakes with deleting too soon that they just issued an edict. You may no longer delete anything in C++. You can allocate all you want, you may not delete anything. So what happened? Programs would run on these servers. Eventually it would run out of memory and they just reboot it. Right? It's designed, it would take a while to run out of memory. It's designed to have lots of redundant servers. And so rather than put up with programmer mistakes, have to do a deletion, they just put up with rebooting the servers every now and then. It's a problem solved. So garbage collection is a big win. It takes that burden off of you. Okay, let's add a couple more things to the list and then we'll be done. You haven't mentioned, I mentioned it, but you haven't mentioned, I think, a big example of something that helps with writing big programs. Yeah?
Variables?
Well, yeah, variables, that's true. I'm thinking of something. Yep. Well, the Java virtual machine lets you compile once and run on many places. Yeah? Well, the stack and the heap, that's related to garbage collection and implementation technology. Yeah?
Debugging?
Well, okay, that's getting at it. But besides debugging, what I'm going to say is what's the generic word for Eclipse? IDE. IDE. That is such a huge change from when I learned to program. So Eclipse can be really intimidating at first because you got all these bells and whistles and options. They're there to make it easier to deal with large programs. When I learned to program, basically, essentially I had something like a notepad to program with. And it was up to me to keep track of all the files. And there may or may not have been support for debugging. Maybe all I could do was put print messages in to do the debugging. It's hard to exaggerate how much of a win having an environment like Eclipse or Visual Studio is. So anyway, as you go forward, what you need to continue to appreciate is that when you're studying programming languages, ask yourself, how does this help with writing big programs? That explains why languages are the way they are. Okay? And I'll see you on Tuesday.
Perfect timing.